Hello, I am Mrs. Miller, and I am going to introduce you to solving systems of equations using the equal values method. Our goals today will be to solve systems of equations using the first of three methods, and we will look at the definition of the substitution method and how we use that to solve for two variables. We will work together to communicate the process and validate our solutions. And that leads us to our essential question. How do we solve for multiple variables? What do we do when our equation has an x and a y? So the first thing we need to understand is what exactly is a system of equations. A system of equations is a set of two or more equations that have a common solution. So here we have y equals 10x minus 2 and y equals negative 3x plus 8. Both of these 10x minus 2 and negative 3x plus 8 equal the same variable. They equal the same thing. So you can think of it as 100 pennies and 10 dimes, both equaling 100 cents, which is $1. So it doesn't matter how we represent that dollar, it still equals $1. So here's another example. Y equals 5z minus 7 and y equals negative 8z minus 4. So here the 5z minus 7 and the negative 8z minus 4 are equivalent. They have the same value. So what exactly does this look like using substitution? To use substitution, or the equal values method in this case, our two equations have to equal the same variable, meaning we have the same variable isolated in both equations. So here, both of these equations have y equals. When you see that, we want that to signal substitution. And to do substitution, what we do is take the other sides of our equations and set them equal to each other. So this 2x plus 3 and the negative 3x minus 2, we are going to combine into one equation. So some things to notice. We go from two equations with two variables to one equation with one variable. That is the purpose of using substitution. So what exactly does this look like in terms of solving? Well, once we make that substitution, our equation 2x plus 3 equals negative 3x minus 2 looks an awful lot like what we did first semester when we were solving equations. So we are going to rewrite our equation. 2x plus 3 equals negative 3x minus 2, and we are going to begin to solve for x. Remember, our steps are to look for anything we can simplify on the left or simplify on the right. Then we are going to look at getting our variables together. So I have a 2x on the left and a negative 3x on the right. So what I want to do is get those x terms together. So I'm going to add 3x to both sides. Here I have 2x plus 3x is 5x plus 3. Negative 3x plus 3x becomes 0. And then minus 2. So we got our x's together. Now I need to work on isolating that variable. So the first thing I need to do is get rid of this plus 3. So I am going to subtract 3 from both sides. I'm going to use my inverse operations. So 5x remains on the left, and negative 2 and negative 3 is negative 5. Now I need to get the x completely by itself. So I have 5 times x that I am going to undo using division. So then I have x equals negative 5 divided by 5 is negative 1. So my solution to this system is my solution for x is x equals negative 1. Now I know part of my solution, because remember, we're looking at this system. Y equals 2x plus 3 and y equals negative 3x plus 2. I know the value of x now is negative 1. How do I get the value of y? So what we are going to do is take what we know x equals negative 1, and we know y equals 2x plus 3. We're going to make a substitution. We're going to replace the x with negative 1. And let's see what happens. So we get y equals 2 times negative 1 plus 3. 2 times negative 1 is negative 2 plus 3, and we get negative 2 plus 3 is positive 1. So we get y equals 1. Well, how do we know that these two here form our solution? We have another equation we can check. So I am going to verify my solution by using y equals negative 3x minus 2, and we're going to use the negative 1 for x, and we're going to use the positive 1 for y and see if this works. So negative 3 times negative 1 is positive 3. Positive 3 minus 2 is positive 1. 1 does equal 1. This definitely works. So my solution is the ordered pair negative 1, 1. In our system of equations, when x equals negative 1, y equals 1 in both cases. There we go. That is using equal values method substitution to solve a system of equations.